Morning. How are we doing this morning? Excellent, excellent. My name is Brian Nice. I am here to give you a good session on planning and deployment for Edge Server with Lync 2013. What I really want to accomplish in this session is to help demystify what the purpose of the Edge Server is. And we'll explain that not only through the features and functions that you would expect to provide for the Edge Server, but also a good understanding of the architecture that the Edge Server provides for us. Talk about some of the common misunderstandings that we have with regards to Edge. Edge is one of my favorite topics that I deal with on Edge, or when I deal with on Lync. And there's a lot of misunderstandings that come about with the Edge service itself. So we want to try during this session to highlight what the purpose of Edge is and kind of clear up any miscommunications that may be out there with regards to how the Edge services function. And then kind of tie that back into what our best practices should be for deploying the Edge role. Right, so at the end of all this, your takeaways should be understanding what the requirements are to deploy Edge. And when we say Edge, I'm really talking about the Edge services that complement Lync all up. So Edge services, reverse proxy, and so forth. So we'll get a chance to discuss both of these topics throughout this session. And you want to be able to try to deploy the best possible design, right? And the only way that you can do that is to fully understand how the solution should be architected and how the solution should function, and then you can translate that into a good design for your customers and for your clients. So here's our agenda. It looks pretty intimidating, but it's not. It's not quite that intimidating. But we do have a lot to talk about with regards to Edge. Right? We're going to start off with the simple stuff, which is why. Why do we even need Edge? What's the point? Right? What happens if I don't deploy Edge for Lync? What am I missing out on? Right? What are the components that are required to deploy Edge? Right? So I tell you a little bit about why we need it, and you kind of go, I think I might like that. What do I need to do to deploy it? Well, we'll talk about what components we use for Edge. I'll take you through what the sign-in process looks like when we have an Edge environment involved. That has changed a bit from 2010 to 2013, so I'll make sure to highlight those areas where applicable. We'll get a good talk of signaling versus media. One thing that I talk about a lot in Lync is the distinction between signaling paths and media paths. Right? My background is in telephony and networking and other glorious areas, but from the telephony world, the concept of signaling and media is pretty much ingrained in your head. From the staunch Microsoft world, it may not be. So I want to make sure that we clarify when we're talking about Edge services and even Lync in general, we always need to keep that separation in our mind of what's the signaling path and what's the media path, because they're not always the same. Right? And that's going to be very true when we start looking at the Edge deployments. We will talk about our friend, the reverse proxy. We'll talk through DNS inserts, because that's a key component that we have to deal with when you're planning and then deploying the Edge roles, making sure you have the right names in DNS, you have the right names on your certs, and all those good pieces. Talk a little bit about networking, the wonderful port ranges that we have with regards to Edge, and the ever-popular 50,000 to 59,999 port range. Talk about our friends, the load balancers, whether we're doing DNS load balancing or hardware load balancing, and which one's applicable where. Touch on HA and DR aspects, how Edge fits into your HADR strategy. Right, I'm not going to go deep dive into HADR. There was a session on Monday that went into the high availability and disaster recovery concepts for Lync all up. I'm going to focus on the Edge piece of that and how that fits into your HA and your DR models. And then we'll finish up our discussions with sizing, placement of Edge pools, and how we validate to make sure that our Edge is deployed properly. So a little bit about me. I live in Southern California in a city called Mission Viejo. I've been with Microsoft since 2011. I'm a UC voice architect in the Microsoft Consulting Services Voice Center of Excellence. They don't give me business cards because it just doesn't fit on a business card. So I've been doing consulting work for about 15 years now. I'm a certified master and a certified master in Lync 2010 and a certified solutions master, as they call it now, in the communications track. When I'm not doing architect work, I also help to develop and instruct the master's curriculum. This is my email and my SIP address that you see up at the top. And in the top right corner, that's my drum kit that I have at home. When I don't do technology-related stuff, I play music. So let's start with the simplest of simple questions. Why? Why do I even need an Edge? Right? Because invariably, you're going to be doing deployments of Lync, and one of the first questions that comes up is, how many servers do I need to deploy this solution? And every time you introduce another server, the customer or your own IT folks are going to go, why do I need that server? What's the justification for it? Well, there are a number of scenarios that the edge services provide for us, right? We break them down really into 4 chunks, if you will, right? Remote user access, federated access, anonymous access, and what we call the public IM connectivity components, right? So if we look at the first column, remote user access, that is the ability for your users that are in your corporate environment to be able to utilize the Lync platform outside of the environment without requiring any sort of VPN technology. That's what we mean by remote user access. And you can see by the checkboxes there, we support all of the modalities for you, right? It's effectively just like you were using Lync inside the corporate network, but you're outside the corporate network. If anybody's familiar with Outlook, you're familiar with the concept of Outlook Anywhere, right? Where you just go home and you open up Outlook and it just magically works. That's what Edge provides for us for Lync, right? The ability for you to work anywhere, anytime, and just open Lync and it just works. You don't have to, oh, God, I forgot to fire up my VPN, and I got to do this, and I got to do... No, you're at Starbucks, and you want to use Lync, you open Lync. You're in the office, you want to use Lync, you open Lync. That's what remote user access is for us in the Lync world. Now, the second column is federated access. That's expanding our reach, right? My organization has Lync deployed. Your organization has Lync deployed. I want to be able to reach you with my Lync client to your Lync client. That's a process we call federation. Right? And we do that through the edge components. So now you can take the SIP address that I gave you earlier on the slide. If your company has Lync deployed and you are federated with Microsoft, you can add me into your buddy list. You'll see me there. You can IM me, presence, all the checkboxes that you see there. You can do any of those modalities with me, just like you would any other user that's in your environment. That's the joy of federation, right? And we can do that with companies that are running Lync 2013, 2010, OCS. We have a lot of power in how we can use this federation process. The third column is anonymous, right? Providing the ability for anonymous folks to join our meetings. Right? So I have Lync deployed, I fire up an online meeting, and I want to invite some folks that are outside of my company to be able to join my meeting. And I want them to be able to join it maybe from an organization that doesn't have Lync deployed. Right? So they're not going to come in as a, quote, federated or an authenticated type user. They're going to come in as an anonymous user, as a guest, if you will. That's fine. We can support, as you see, the modalities that are there through Edge services. Right now, they don't get presence, they don't get IM, they don't get one-to-one audio-video for anonymous. Right? That's not the point. This is joining a conference, right? So it's multi-party. So that's what the anonymous column is. And then the last column is what we call PIC or /XMPP. PIC is the public IM connectivity, which is what allows us to connect to the public providers such as AOL, Skype, was Yahoo for a while, but not so much anymore, right? MSN, which basically becomes Skype. And then also XMPP, which up until recently we could use to talk to things like Google Talk, until Google decided to remove XMPP support from Google Talk, so oh well. But the Edge is going to provide that capability. And again, take a look at the checkboxes that we see. IM and presence, peer-to-peer, right, one-to-one. Audio, one-to-one for Skype and traditionally what was called MSN, right? And video right now was MSN, right? Now that we're in that transition over into the Skype world, it's not anymore, and video is on the roadmap to be available between Skype and Lync. So Edge provides a lot of the functionality. And again, I have the little bullet there that Skype's going to replace MSN soon. Well, it's here now for the IM and presence and audio piece. The video piece is still in the roadmap. So lots of scenarios that you could miss out on if you don't have Edge services deployed. You know, being able to expand that reach, that collaborative reach from your company out to the world. So, what else relies on the Edge server? Well, obviously those first bullets you see there, remote user, federation, anonymous users, PIC. Yeah, we covered that on the table on the last slide. Perfect. But there's more, right, that the Edge server functions with. The mobility clients leverage the Edge server, right? Specifically the mobile 2013 clients for audio and video, right? When they're invoking media, they're going to use the Edge services for media, right? So if you think, oh, I want to deploy the Lync 2013 mobile client, I don't need an Edge server. You do if you want to do audio and video with those mobile clients, right? Push notification support for the Windows Phone platform. We need to go through Edge for that. Lync web app The plugin for Lync web app for audio and video, for media, we're going to use Edge, right? If we're using hosted Exchange I've deployed Lync on-premise, I'm doing enterprise voice on-premise, that's great, but I'm using O365 in the cloud for email. I can light up in the cloud, and I can connect to the hosted Exchange environment through my Edge servers, allowing me to use on-premises Lync for voice and cloud Exchange for voicemail. So that's where our O365 integration point comes in, through our Edge services. So the Edge scenarios are extremely critical scenarios that we need to be aware of when we're planning for and going to deploy the Lync platform. Question that we always get is, well, what about using VPN? Why don't I just use a VPN instead of Edge? Well, first off, most of the items that are there you can't do with simply VPN. Right? The mobility clients, not going to happen with VPN. Right? Lync web app, hosted Exchange O365 integration. None of that's going to happen with VPN. About the only scenario that you could make happen with VPN is remote users. And even then, the experience is not going to be a pleasant one. Right? And that's just simply because VPN is ignorant about the traffic that's going across it. Right? Traffic goes across the VPN, we need to encrypt it, and we need to secure it, and we need to get it to the other end. Well, you gave me data, I just chop it up and encrypt it and send it on its way. Well, this is real-time data. This is fragile data. We don't want to be doing that. Well, VPN doesn't care. Right? So the person on the other end gets choppy conversations or poor audio quality or whatever. This is why we developed Edge services, so we don't have that extra overhead. Not to mention, Lync already encrypts everything anyway, so try encrypting something that's already encrypted. Doesn't work out so well. Right? And the performance tends to degrade from that perspective. The PIC side of the house, the public internet connectivity, or public IM connectivity as we call it. Right? We do list MSN here, but essentially MSN has pretty much been subsumed by the Skype components now, because as you know, when you're using Skype connectivity, you have to sign into your Skype client with what we call a Microsoft account, or what was formerly a Live ID. Right? You need to sign into your Skype client with a Microsoft account, and then you have the capability of doing peer-to-peer audio, IM, and presence via the Edge services for Lync. AOL is still available, right? We make a little note here about the certificate requires a client EKU, that's an enhanced key usage. I'll talk more about that a little later when we get to the DNS and certs section, but that's just a little footnote if you're going to be configuring PIC connectivity with AOL. Yahoo, it's still there, but you can't buy it anymore. Right? It's going away as of June 1st, 2014. And the main reasoning for that, I mean, basically the Skype, the AOL, that's included if you have software assurance on your licensing for Lync, you automatically get to federate with those guys. Yahoo was an extra per user per month fee that you had to pay to be able to federate with Yahoo. And Yahoo has since discontinued that and is no longer going to provide that service. XMPP, again, it's there. It was there for Google Talk. Recently, Google announced that they're removing XMPP support from Google Talk. So, oh well, we're not going to have that option anymore until Google decides to either open that back up or find some other way to allow us to connect. But it was there. It seems it's not anymore. Yeah, that was a question. Like Cisco Jabber? So the question is like Cisco Jabber. I don't know if they've removed it from Jabber or not. I know they removed it from Google Talk. I don't think they removed it from Jabber, but if they do remove it from Jabber, then yeah, we won't be federating with Jabber anymore either. So keep closing themselves off, it'll be fine. So the components to make Edge work. There are actually 4 specific components that we talk about in regards to the all-up Edge concept. Okay? 3 of these components run on the same physical box. Okay, that's the Access Edge, Web Conferencing Edge, AV Edge. Those 3 components actually live all on one server. The reverse proxy is a different server. Okay, I'm going to come to that in a second. First, the Access Edge. The Access Edge component is responsible for SIP. Right? That's what we use for our signaling. That's what we use for all of our channels for IM and presence and signaling and all that good stuff. It's all over SIP. The Access Edge is the SIP component for external connectivity. The Web Conferencing Edge server is what handles what's called PSOM, or the Persistent Shared Object Model. This is what's responsible for web conferencing. PowerPoint sharing, that should have a little asterisk next to it, right? Because PowerPoint sharing The asterisk would be for legacy support because we have a new role in Lync 2013 called the Office Web App Server. That's actually going to help us with PowerPoint sharing. But if we had legacy clients or 2010 clients or something to that effect, we would utilize Web Conferencing Edge for PowerPoint sharing. We still continue to use the Web Conferencing Edge for whiteboards, annotations, and polls because all of that is done via PSOM, which is what travels through the Web Conferencing Edge role or Web Conferencing Edge service that lives on the Edge server. The one that's probably the most interesting to me, and again, I don't get out much, but it's interesting to me, is the AV Edge server. Because this is the one that's responsible for the media flows, right? He's responsible for the secure RTP, the SRTP traffic, which is the media channel, right? Remember we said earlier there's a difference between signaling and media, right? Signaling goes to Access Edge, media goes to AV Edge, okay? Audio, video, file transfer, app share, all of that is happening through the AV Edge role. We'll dig more into that role as we go through the traffic flows in a little bit. So those three run on the same box. Right? Same physical system. The last one's the reverse proxy. And this one's kind of the annoying one at this point, right? Because effectively the job of the reverse proxy is proxying web traffic, specifically HTTPS traffic. That's what we use for address book sync, the Lync Discover service, meeting content, Lync web app itself, Office web app server, right? All these things come through the reverse proxy. And all of our documentation will point you to utilizing Forefront TMG as your reverse proxy, right up until they discontinued it. Bam, yeah. Of course, our documentation still says you can use it. Sure, if you happen to still own it, but you can't buy it anymore, right, because they've discontinued Forefront TMG. Next logical question becomes, well, we have UAG, right? Nah, we don't support UAG. So there are other options. We'll dig into reverse proxy a little bit later in the deck, but for now, just know that that particular component is responsible for the web roles. You have to have this component. Okay, I've been involved with a number of customers that they look at Edge and go, yeah, we'll deploy the Edge server. Yeah, we don't need that reverse proxy. Yeah, you do need that reverse proxy. Look at the list of things at the bottom that are simply not going to work without that reverse proxy. Right? Lync web app. Oh, you want anonymous users to join your meetings and you want them to get in and use that cool web interface we gave you? Not without a reverse proxy, they won't. Right? We need to have mechanisms to be able to get that web traffic into the internal environment. And that's going to be the job of the reverse proxy. So more to come on him in a little bit. So we have a quick understanding of the components. Now, how do we use those components? First thing, you got to get signed in, right? We can't use any of the other components unless we sign in first. Now, I'm going to take you on a little bit of a historical journey here, right? We're going to talk about what the sign-in process looked like in 2010 and how that sign-in process has changed in 2013. So here's my setup, right? You can see I have my Lync client on the left, public DNS server. I'm at my home office, whatever. I could be at Starbucks, what have you. And you can actually see I have two data centers here. Data center 1, data center 2. The only difference, data center 1 happens to have a director, no biggie. But a couple of pools there, we've got Edge, we have reverse proxy. Now, in Lync 2010, when the client wants to sign in, it does a query in DNS for a specific record type, and we call that an SRV record, or a service locator record. And that's the record I look for, _sip._tls. Whatever my SIP domain is, right? So for us, it's Microsoft.com. So I look for _sip._tls.microsoft.com. It's going to return back, hopefully if it's configured right, the Edge server's name that we have configured for the Access Edge service, which could be something as very mundane as sip.microsoft.com, right? Could be whatever you want it to be, really. Generally, we will see things like SIP, what have you. So we return that record for DNS. We connect to that Edge server. Now, the Edge server knows, by the topology that we've created, that his next hop, in this case, is the director. The Edge server does not authenticate anybody. The Edge server is not capable of doing authentication. He's not a domain member. He doesn't know anything about credentials. He doesn't authenticate. All he does is validate, oh, this is Brian at Microsoft.com. Oh yeah, Microsoft.com is a valid SIP domain for me. I'll pass this on to my next hop. Okay, but he doesn't know who I am. He just knows what SIP domain I'm trying to sign in for. You're authoritative? Oh yeah, I'm authoritative for that domain. Move on to the director. The director will take care of doing the authentication. Okay, no authentication on Edge. The director's job, authenticate and find my home pool. right? So I could be a user that's homed on the pool that's in data center 1, so I get directed there, or I could be a user that's homed on the pool that's in data center 2, so I get directed there. Nothing really magical about that, but that's the workflow that we have. Challenges that we see with this workflow, of course, is the SRV records are all pointing to that edge server that's in data center 1. Well, what if that data center is in North America and data center 2 is in Europe? And what if I happen to be a user that's homed on data center 2 in Europe? Well, my sign-in process has to go through the edge servers that are where? North America, right? So I have to go across the pond to hit the edge pool in North America so that I can hit the director to realize that I need to come back across the pond to sign into my pool. Not terribly concerning because SIP traffic is pretty light, but still not the optimal way to do things. We fix this, or we should say we address this. Right? I want to imply fix because it worked, right? We address this in Lync 2013 by utilizing Lync Discover services, or Auto Discover, as you might be familiar with, right? Exchange uses the same concept. Now we're using it in Lync. My Lync client will now query for a particular A record called linkdiscover.mysip domain. So again, linkdiscover.microsoft.com. Well, this one's not going to go to the edge, right? Because this is a web URL. This is a web query that we're doing. So enter the reverse proxy, right? I need to get to my reverse proxy because I need to be able to resolve that Lync Discover request. Now, the cool thing is when I send this request in via the reverse proxy to the front end, he's going to return back a whole list of URLs for me, including which edge server I should connect to. So he can now respond back and go, oh yeah, you're in the European pool. Go to the European edge server, right? Don't go over to North America. Go to the Europe edge server, right? So the bottom dotted line, oh, you're on the Europe pool. Go talk to the Europe edge server. Oh, you're on the North America pool. Go talk to the North America edge server, right? So now we're starting to get some more intelligence to be able to say, let's get you connected to your local edge as opposed to having you connect to a singular edge pool, which we would do with our SRV records, right? And then have to get, kind of ping-ponged around in the environment. Remember, this is signaling we're talking about, okay? So first layers first. When we sign in, we're dealing with signaling. This is something that was new in Lync 2013 for the clients, right? Now, a lot of you may be looking at me going, he doesn't know what he's talking about. Lync Discover, we added that in like CU4 of Lync 2010. Yeah, we did for the mobile clients. But it wasn't until Lync 2013 that the actual fat client took advantage of the Lync Discover process. Okay, so back in the Lync 2010 days, yes, we did have you create records for Lync Discover or Lync Discover internal and all that stuff, but it was strictly for the mobile clients back then. Now all of the clients will leverage this Lync Discover process.
I noticed that you're missing a director.
Yeah, I wouldn't say I'm missing it, Bob. So no. Y'all got that? That's great. Yes. It's a good catch. He said I was missing the director. If you look at the previous slide, if I go back, there was a director here. It's purposely not there because in Lync 2013, because of this intelligence that we have now in Lync Discover, there's not much of a point to have a director anymore. Right? The directors have really been pulled out of the spotlight. Now, that's not to say they don't have a purpose. Right? If you get involved with certain customers and certain security folks, right? They may not like the concepts of not having a director and want to have like that traditional next hop from edge to director and you're still fully supported to do that, right? But yeah, with relying on the director, not really needed much anymore. Now, we like Lync Discover. That's our primary method. But you got to configure it right. Okay, there's two records, Lync Discover internal and Lync Discover, and you have to make sure that these are configured properly. What I mean by that is Lync Discover internal should only ever resolve inside of your organization. Right? Don't ever put that record in your external DNS. Not a good idea. Likewise, Lync Discover.whatever.com needs to only be in your external DNS. Don't put that in your internal DNS. Right? Because the client is going to make decisions, oh, if I resolve Lync Discover internal successfully, I must be inside the network. If I resolve Lync Discover, but not Lync Discover internal, I must be outside the network. And you don't want to create a scenario, unless you've properly planned for it, right? You don't want to create a scenario where the client is actually inside the network but thinks it's outside, because then it'll try to connect to the edge, right? Even when it's inside your corporate network. Now again, if you plan for it that way, then great. But you don't want that to happen accidentally, and you suddenly go, why are they inside the network and connecting through Edge? I don't get it. Well, check to see that you've got these records set up right. Right, Lync Discover is our preferred sign-in method. Now that means to protect this, we need to protect those simple URLs, and typically we're going to use something like GeoDNS, to make sure that when I resolve linkdiscover.whatever.com, it doesn't just resolve to one server, right? But it could resolve globally, and I could use global load balancers, to take care of that. It's just HTTPS. It's not that terribly complex. If that's not your cup of tea, or you haven't gotten Lync Discover configured yet, fear not. The Lync client will still sign in because it can fall back to using the traditional model that we used in Lync 2010. Right, so go and find the DNS records, and there they are. There's a whole list of them that we're going to try for to be able to sign in. The exception to the rule is, of course, the mobile clients and the Lync Windows Store app. Those have to have Lync Discover configured, or they just won't sign in. Okay, so if you've gone ahead and you've got your shiny new Surface, right, and you load up the Lync Windows Store app and you go to sign into it and it doesn't sign in, make sure you have linkdiscover.your SIP domain as an external entry and it's pointing to reverse proxy and all that. Because without that record, that Lync Windows Store app just won't sign in. Right, you'll end up going, well, I can sign in with the Lync client. That works fine. Why doesn't this Lync Windows Store app work? So make sure you have the Lync Discover entry available. Speaking of which, the value of the director, there's still value in it. It's just not quite as valuable as it used to be, right? Because we have additional intelligence that's built into Edge, additional intelligence that's built in with Lync Discover. So the things that the director used to provide great value for have been diminished, right? Now, that's not to say if you've deployed Lync 2013 and you've deployed directors that you've done anything wrong. That's fantastic. They still work exactly the same as they did before in 2010. It's just they may not be as valuable as they once were. And especially when you start having discussions with customers and they, wow, I want to reduce my server count. It's usually one of the first ones that gets put on the chopping block is, can we really justify having another set of servers as directors just to be next hops for Edge or just to be for sign-in and redirection purposes? Only one, yes. So the question is, what if you don't have split DNS, you just have one DNS zone, what do we do for Lync Discover? Hold that question until I get into the DNS section, and then I'll take you through it, okay? Cool. Yeah, one more question.
For directors, if you have more than one site, or more than one pool per site, would the directors still be useful then?
The question is, if I have more than one pool per site, would directors still be useful? They could be. The front-end pools are capable of doing everything that a director can do. So if you have the VMs or the hardware to spare, it certainly provides another layer, right? Because you're kind of taking that load off of the front-end pool. But even still, you could point multiple SRV records to, and even multiple, Lync Discover records to each of the pools for availability purposes. So that's why it could still work, but it's a tough sell now. All right, signaling and media. Signaling is independent of media, right? That should be a common theme when you're talking about Lync in general, right? Because the signaling paths and the media paths do not have to follow the same logical structure. So here we are. I have two data centers. I have the US data center. I have the EU data center. This particular user is homed in the EU data center. And let's say from a signaling perspective that he happens to sign in through the Lync Edge pool that is in the US. Right? Perhaps we don't have Lync Discover configured, or maybe we do have Lync Discover configured improperly or something to that effect. And it's, we've got this guy signing in through the US Edge pool. Not a problem, because remember, we'll fall back to SRV and, life is good. So he signs in through the US Edge server. We hit the next hop and he says, dude, you're not here, you're over there. And life is good, I get signed in. Now I go to pin up an audio call. Well, guess what? I will always, always, always use the Edge pool that is associated with my home pool for media. Right? So just because I did signaling through the Edge server in the US does not mean that my media will flow there. In fact, my media can only ever flow to the Edge pool that is associated with my home pool that you see there on the right. So when I deploy the EU front-end pool, right? One of the things we do in Topology Builder is there's a little checkbox that says associated edge pool for media, right? And then you'll tick that and there'll be a little drop down and you can pick which edge pool you want. That's creating what we call an MRAS, a Media Relay Authentication Service, an MRAS association between the edge pool and the front end pool. So in this case, when I deploy it, this edge pool that's in Europe will be an MRAS associated pool to this EU home pool. That means anybody that's homed here in EU has to use the EU edge pool for audio and video. Right? That's because of how we do authentication, right? You're not on the US pool, which means you're not authorized to use this edge server. You're not authorized to use his AV edge services. MRAS will just go, no, you need to go use this guy over here. Right? So an example of how signaling becomes independent from media. Yeah, maybe I sign in to the US edge pool for SIP, but I use media local. And that's why this never really was that big of a problem in the Lync 2010 days, before the whole Lync Discover thing came about, because the fact that we did signaling across the pond wasn't that big of a deal, because SIP signaling isn't really that heavy, right? What's the heavy part? Media, right? The heaviest part is media. Well, we are going to keep that local when he's in EU, right? Because he's going to be using the European edge server for AV. If a user creates meetings in EU, and people join that meeting, right, and they want to join anonymously, for example, use the Lync web app, they're going to be using the AV Edge server that's in Europe, right? So you have to think about that from a planning perspective, right? I have users that are in Europe, they're creating meetings, and maybe they invite 50 people from the US, and all 50 people in the US are not, Lync users. They're all using kind of Lync web app. Well, they're going to be going across the pond for audio, because we're going to be using the audio-video services over in Europe. Right? So we have to make sure that we plan for that or understand that when we get into that particular kind of scenario. But wait, there's more. Federation. What about the flow of federation, right? Because federation is an interesting creature, because when we configure it inside of Lync Topology Builder, we have to select the federation edge, right? We can't all be the federation edge. We're not all special. We have to pick one of the edge pools to be the federation edge pool for signaling, right, for SIP. So again, here we go. We have a US data center. We have an EU data center. Our friends in Contoso. There's my guy that's homed in Europe. We have our federated organization of Litware on the right side, right? They happen to be in Europe as well. We've gone in and configured the US pool to be the pool that we use for federation. Okay. Right, maybe that was the first pool that we deployed, and we said, yep, that's the guy we're going to use for federation. Okay, problem. They only have the one edge server in the diagram, so it's pretty easy, right? That's the edge pool that they chose for federation. So now, here's my user that's in Europe. He wants to talk to somebody over in Litware. So we're federated. I fire up my IM window, and I start chatting with Bob, over there in Litware. That signaling path is going to flow through the US edge, from the US edge, over to Litware's edge, and to that particular user's home pool, and then, of course, back to his client, so that we can chat. That's our signaling path. And again, it's signaling, so it's not really heavy. I mean, you may look at that and go, oh, it's going from the US to Europe, and it's SIP. Web traffic does it all the time, and you don't really notice it, right? SIP is just not that big of a deal. What happens when we now escalate this from an IM conversation to an audio conversation? Or to an audio-video conversation, right? Well, it's pretty easy to know which edge server we're going to use for media on the Litware side, because there's only one, right? But which edge server are we going to use for media on the Contoso side? This is the interactive part, okay? You can say something back to me. It's good. Make sure you're all still out there. Okay? The EU one, right. Because we know from the discussion that I had a couple slides ago that you can only ever use the edge server that's associated with your home pool for media. That applies for federation as well. Okay? One of the common misconceptions is, oh, the US edge is my federation edge. That means all federation traffic, including media, would go from the US edge to the partner. That's not true. Okay, the signaling all goes from the US edge. The media will go from whoever's edge pool, right, that they're associated with their front end pool. So in this case, when we fire up an audio session, The audio is going to go between the edge pool that's in Europe and the litware edge pool, right? Because that's what we need to do from an audio flow perspective. Now, that's overly simplified, by the way. There's a lot of other paths that audio could take. I have a session that I did at the last TechEd on audio-video through ICE and Edge, and it was a 400-level session, pretty deep dive. I've got a link to it at the end. So if you're interested in more about how the actual media would flow, that's a good session that you can go and look at. So I'll give you that link towards the end here. For now, I'm just going to keep it overly simplified so we can get through the rest of the deck. The reverse proxy. Yeah. We like reverse proxies. We like them because they provide access to the web services that we need, right? And that is the internal web services that Lync utilizes. And these web services provide things that range from Lync Discover to Office web app services for PowerPoint to the Lync web app. I mean, there's all kinds of the address book, all kinds of things that happen over HTTPS. So we need the reverse proxy to be able to do that, right? So requirements that we see here. Right? This is what your reverse proxy basically needs to be able to do. It has to support the ability to do SSL and TLS publishing to internal websites, right? It needs to be able to publish with and without encryption, right? So I need to be able to not only do it on 443, but also on 80, right? And that's advantageous in Lync Discover scenarios, which we'll get to in a little bit when we look at DNS and cert names, right? Publishing websites using FQDNs, right? So when you go into Topology Builder and you're defining your pool, you're putting in names. What are the external web services names going to be? What are the simple URL names going to be? The meet, the dial-in, and all that fun stuff, right? We need those names publicly accessible. Well, most organizations aren't going to let you go from the internet straight to your front-end servers, right? That's not going to work. So we need to have some kind of barrier in between. That's the job of the reverse proxy, right? Has to be able to handle search with SANs, because we got lots of names we're going to put on, right? Original host headers have to be sent through, right? We have to know what the original request was from the client. Was it for meet.contoso.com? Was it for dial-in? Was it for insert URL here? And you may have to do some bridging. Right? Bridging meaning the request comes into the reverse proxy on 443, but it sends it to the next hop on 4443. Right? That's what we mean by bridging. Right? So it didn't go straight through 443 to 443. We actually port mapped it. Right? So we need to be able to do these kinds of things. Now, why do we list requirements here? Because quite honestly, Lync does not care what you use for a reverse proxy. Right? Everybody gets hung up on, oh, you got rid of TMG. What am I going to do? Pick a reverse proxy that does this, and you're good. That's essentially the stance that's being taken. Now, granted, that's a pretty overly simplified stance. So as a result, they're starting to put together a program, much like you see for the UCOIP that we have for voice and whatnot, where we list qualified hardware load balancers and software load balancers and whatnot. Well, they're starting pages now for qualified reverse proxies. Right? And two on the list so far are F5 and the IIS ARR process. Question?
Knowing that Microsoft doesn't have TMG anymore, is the direction that Lync is going to take? Are they going to start looking at rolling out those features into the Lync Edge and pulling them off of the reverse proxy? Or is there any? Can you comment on any of that?
Yeah, so the question is, because of the way that TMG has kind of gone the way of the dodo, is there a thought process to maybe combining some of this functionality into the Edge role? And I don't have any visibility into that. I don't know. So it actually piqued my curiosity at the keynote when they talked about Windows Server 2012 R2 having this web application proxy role built into it now, which is capable of doing a lot of these reverse proxy functions, and made me go, wonder how Lync would use that. Yeah. But since I found out about it on Monday, I figured I wouldn't put it into the deck on Wednesday. It probably wouldn't work out so well. Anywho. So we need to publish specific FQDNs, Lync Discover, the web farm, simple URLs, the Office web app server, or what we used to call formerly the WAC server. You'll hear it called the WAC server because that was the sound that we used to make when our head hit the desk trying to deploy it in the beta phase. Now, it used to be the Web Application Companion server, which is now called the Office Web App Server. We use it for PowerPoint, specifically for read access to PowerPoints. We have to bridge 443 to 4443 for every FQDN that we publish except Office Web App Services. Okay, Office Web App Services goes straight through 443 to 443, right? But everything else gets bridged, right? And the reason it has to get bridged is if you've ever taken a look at your Lync servers, right, and you open up the IIS admin tool, you're going to see two websites in there, internal web services and external web services. The external web services IIS site listens on 4443. So that's the reason why we bridge these, is to make sure that the requests that are coming in through the reverse proxy actually end up on the external web services website and not the internal web services website. Okay, so very important not to miss this bridge to 4443, otherwise certain things don't work. And there is optionally bridging port 80 to 8080. That's very useful in the Lync Discover realm when you have multiple SIP domains, right? Maybe I've got a customer that has 25 SIP domains, and they're like, I'm not buying that many, Lync Discover dot names for my cert. I'm just not going to do it, right? So we could actually bridge 80 to 8080. They could make the initial Lync Discover request over HTTP, and then the redirect will get them their external web services, which will be over 443. So there's an option to bridge that if you so desire. Yes?
Do you think of reverse proxy differently? In your diagram, I saw reverse proxy. Your United States data center and data center. I'm thinking when I read about reverse proxy, I'm thinking, I can put it up at my third site, like my fourth site, redirect traffic to my two, front ends.
Mm-hmm. So the scenario that was mentioned is looking at reverse proxies. Instead of having them in data center A and data center B, possibly having the reverse proxies simply be in data center C and have that kind of do what it needs to do. Theoretically, you could do that, but our architecture, you would have reverse proxies in each of the respective data centers. And then for URLs that are common across the environment, like we're going to get into here, like Lync Discover, Meet, Dial-In, and so forth, you would use like a GeoDNS load balancing solution to say, well, if you're in the US, when you query for meet or Lync Discover you go to the US reverse proxy. But if you were in the EU and you query for that same thing, we send you to the EU reverse proxy. That's how we would do the DR aspect. Okay, DNS and certs. Lots of names, lots of cert options. First off, the reverse proxy cert should be a publicly accessible cert. So a VeriSign, a Komodo, or whatever, right? Go and find a public provider and use public certificates. Main reason for that is because, when you have things like the mobile clients and whatnot that need to query using SSL, if it's from your internal CA, now you have to deal with certificate trusts, and how do you get the root cert on there, and how do you get the CRL access, and blah, 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 blah. If it's a publicly accessible cert, there's a reason why you actually pay money to get public certs, because those root certs are already baked in to the OSs, right? So we implicitly trust those particular providers. The reverse proxy will be the launching point for Lync Discover, your simple URLs, your Meet, your Dial-In, and so forth. Your external web farm FQDN, right? When you define this in Topology Builder, you'll give it what that URL is. That's the URL that we use to access things like address book services, the Lync web app, and so forth, distribution group expansion. You also need a cert name for the Office web app farm, right? Which could be something as simple as, owebapps.microsoft.com, or something as, unoriginal as WAC1, whatever. Whatever name you use for the WAC pool needs to be on this reverse proxy certificate as well. All of that's HTTP, right? So all those names in the top there for reverse proxy, all HTTP traffic, HTTPS secured, right? On the edge server, there's two sides to an edge server. There's an external side and an internal side, right? When you look at our documentation, edge server documentation states you must have a minimum of 2 network adapters in your edge server on 2 distinct non-routable subnets, right? So an external facing side and an internal facing side. Invariably, I will get asked the question, can't I just do it with one NIC and then kind of do some kind of Windows-based routing? Can you do it? Sure. Are you supported? Absolutely not. Right? We will not support you doing that because the edge server is designed to have an ingress-egress for external and internal. It's designed to be forked in that fashion. Right? It's not designed to have the Windows OS determine which routes things need to take. Right, so we have our external interface, Public certs, 2 names, real simple. Whatever you're using for Access Edge, like sip.microsoft.com, and whatever you're using for your web conferencing edge, like webconf.microsoft.com. Yeah, real original, I know. But that's it. And you can achieve that all with 1 cert, by the way. Right? I don't have to buy 2 certs. I can buy 1 cert, put the Access Edge FQDN as the common name, put the web conferencing edge as the subject alternate name, done. And then just put that cert across all of my edge servers that are in that particular pool, and we're good to go. The internal interface could be a private one. It could be a public one, but I mean, the internal interface, it's only really connected to internally by your internal clients. So generally speaking, you don't have to spend money on a public-facing cert for the internal interface of Edge. So generally, you would use your internal CA. Question?
Are wildcard certificates allowed?
Wildcard certificates. For the reverse proxy, wildcard certificates are supported. For the Edge server, they are not. So you cannot use wildcard certificates on Edge at all. You can use wildcard certificates in the subject alternate names, okay, on your reverse proxy. Okay, you cannot have a wildcard name in the subject name. We don't support that, right? So you can put, linkdiscover.microsoft.com as the subject name and then star.microsoft.com as the SAN name and put that on your reverse proxy and we're happy. Right? That's the only place that we can do wildcard certs. Private certs on the reverse proxy side will definitely cause problems if the root's not trusted, number one, but if the CRIL can't be accessed, that's the certificate revocation list, if that can't be accessed, that's a problem too. Invariably, I run into customers that have set up certificate services improperly, meaning they were trying to get cert services up, they didn't know what to do, they found some guide on like Cisco site or something and said, here's how you deploy certificate services, and they kind of next finished, and now we have a cert serve called cert serve. So you go to certserve/cert serves, and we didn't define a CRIL outside of Active Directory, right? It's all in AD, so your client's external can't get, it just blows up, right? So unless you've actually deployed certificate services properly and you've properly distributed root certs, it's not a good idea to use private certificates on your reverse proxy. It's just going to cause more trouble than what it would be worth to go to VeriSign or whomever and just get yourself a cert. You do not need to put the AV Edge Server FQDN on the cert. Right? When you're going into Topology Builder, you'll give a name to the AV Edge, which usually you'll use av.microsoft.com, right? That just needs to be resolvable in public DNS. That's it. It is not a name that gets put on your cert, right? It doesn't have to be there. It doesn't hurt if you put it there, but there's no function for it. We will never connect to that name with a certificate request. Speaking of that certificate, there's a new feature we brought into 2013, which is called the Rolling AV Authentication Certificate. Now, to appreciate this, first we need to understand what the job of the AV certificate is. And it has to do with that thing I mentioned earlier called MRAS, right? The Media Relay Authentication Service. In order for me to allocate media on an Edge server, I have to be authenticated to that Edge server, right? In order for me to be authenticated to it, I have to have a token. Because remember, the Edge server can't authenticate me as Brian, because it's not in a domain, it doesn't have Active Directory, it doesn't know who I am. But I can have an MRAS token given to me, and I can present that token to the Edge server, and he'll go, yeah, you are allowed in, right? Because you have this MRAS token. Well, the construction of that MRAS token is done utilizing this AV authentication certificate that's placed on the Edge servers. You get this token when you sign in, or every 8 hours after that, right? So I sign in the morning, I get an MRAS token. And I leave my client sit. After 8 hours, I'll renew that MRAS token. Everybody gets an MRAS token. Regardless of whether you come through the Edge or not, everybody gets an MRAS token. So even if I'm inside the network, I get an MRAS token. Right? This also presents itself rather nicely if you have problems connecting to your Edge servers. You might be inside going, why is it taking so long for me to sign in? Or, why is it taking so long when I make a call? I hear this, boop, boop, boop. Why is it doing that? Because it's trying to allocate ports via MRAS to your Edge, and if you can't connect to it, we wait, right? That's why you get these little beeps. So make sure you can connect to the AV Edge services for MRAS, right? What happens when we renew that cert, right? We know that certs don't last forever, right? So we buy the cert, it's got a 2-year lifetime. Great. So the administrator decides that we're going to renew that cert. Let's put a new cert on there. Well, that's great, but there's clients that still have tokens that were issued by the old cert. Well, if you just rip that out and put the new cert in, People that have the old tokens present it to the AV Edge, and he goes, what? I didn't know. I didn't give you that. No, get out of my face, right? And then I have to sign out and sign back in, and then it magically works, right? And then, of course, people that sign in after that, it all works fine. It's like, wow, how am I going to deal with this? That's the concept of the rolling AV auth cert, right? We're able to stage a new certificate and utilize the new certificate while the old certificate is still in place, right? Basically bridging that 8-hour gap of saying, hey, from the time that somebody had issued that last cert, that last token off of the old cert, now we've got a new one. We'll continue to honor those old ones for a certain period of time, 8 hours. And then at this time window, the old cert's now gone, the new cert's now there, but it's been over 8 hours, so everybody's either signed in again or they've refreshed their MRAS token using the new AV cert. Boom. I don't have to worry about it. Right? Now, again, this is not something you're going to do every day, but this is something that will come into play when it's time to renew those AV auth certificates, and you want to ensure that you don't cause an interruption of service to your user population. Right? And there it is, set CS certificate type role, thumbprint, and an effective date. There's an article, I've got a link in a little bit later, that shows you an article on TechNet on how to configure the rolling AV auth cert. So I've got that in the resources slide a little bit later. Okay, so for DNS, there's lots of names, right? I'm not going to go through every single one. This is well documented in TechNet, but there are some highlights that I want to point out that are different in 2013, right? The Lync Discover one, of course, that is quote-unquote new in Lync 2013, right? Yes, I know we added it as a cumulative update to the previous iteration of Lync, but if you are new to Lync, that would be a new record that we have available if you maybe didn't deploy mobility back in the 2010 days, right? The XMPP, right? Previously in previous versions, is that for me? Sorry, I heard somebody's phone ring. I thought somebody was calling me. In previous versions, XMPP was a separate gateway, right? We had a separate XMPP gateway that ran on R2, and you kind of pointed stuff to that, and then it hopped from there to the edge, and it was this really kind of funky thing, right? We've built XMPP support into the edge. There's an XMPP proxy now in the edge server, and then the XMPP service actually runs on the front ends, right? So now you take that XMPP underscore XMPP dash server dot underscore TCP record, and you point that to the edge. And then it doesn't work with Google Talk. But, I mean, the premise is there for you to be able to do XMPP federation. That was the one that we tested. Your mileage may vary for other XMPP platforms, but XMPP is now built in to the 2013 Edge. The SRV records that you see on the right there, that's all the ones that start with the underscore. They actually point to a fully qualified name, which then you have to have a corresponding A record, of course, for that. So that has to be in the same domain as well. So what we mean by that is if I did underscore sip dot underscore TLS dot contoso.com, I could not say, well, this points to sip.microsoft.com, right? Because contoso.com, microsoft.com, the names don't match. If I did that, when I go to sign in with my client, I get the ever-popular pop-up box that says, hey, you're connecting to an untrusted environment, right? Because these names don't match. Do you want to continue? That's not a good experience for the end user. Question? How do they get away with that in Office 365? How much money you got? No, just kidding. They get away with that in Office 365 by using a registry key called Trust Model Data, which actually has all of the O365 names in it. And Trust Model Data is basically a way of overriding that. So if you're in an environment where you need to do that, you have access to be able to go into the Trust Model Data registry key and add your stuff in there. Just word of caution, add, don't replace. Okay? Add your names to the list of names that are already in there. Right? Because if you take the names that are in there out, then you'll bust O365, among other things. Yeah. Obviously, a lot of SIP domains means a lot of sands in the cert, which could be a lot of money, which is one of the reasons you may use Trust Model Data or something like that to get around it. Now, there was a question earlier before I move on what do I do about Lync Discover if I don't have split DNS, right? And split DNS would mean that I'm using contoso.com internally and contoso.com externally, and I have separate DNS infrastructures to manage that, right? Not using split DNS basically means I have contoso.com, and I just resolve that name, and it resolves through the same DNS provider, whether I'm inside or outside. What would I do in that case for Lync Discover? Right? Well, the problem that you run into there, of course, is if you don't have split domain, if you did Lync Discover internal only, then everybody would always be internal, but they're not. And if you did Lync Discover dot, and they're all external, then that wouldn't work either. Right? One of the workarounds that we have for that is a solution called pinpoint zones, where you can actually create a pinpoint zone in DNS specifically for Lync Discover internal dot, or Lync Discover whatever, to resolve to exactly what you want it to resolve to. Right? So that's one of the options that you have. If you want to come up afterwards and get more detail, I'm happy to give you that. The network. It's another area where we have a little bit of fun. Because, of course, we're deploying edge, which means that these things are connected to the internet, which means we need to open ports, which means we need to talk to the firewall guys. Yeah. Talking to the firewall guys could be entertaining. It could be painful. Right? So first thing we need to do is have our ducks in a row and know what it is we need to talk to the firewall guys about. So first thing, the IPs per edge. Now, we're talking external IPs here, right? The external interfaces of edge. Remember I mentioned before there were 3 services, right? Access, that would be SIP. Web conferencing, that would be PSOM. And AV Edge, that would be SRTP, right? So that's the letters that you see there. Now there's 2 schools of thought for how you can approach assigning IP addresses to your edge servers. The first approach, use one IP address for the edge server and have all 3 of those services share that one IP address. Or have dedicated IP addresses. So that would be 3 IP addresses on your edge server, 1 for each service. If you decide to go the first route, what do you see that's kind of different about the first and the second? Right? You look at that first option, well, if they're using the same IP, they've got to listen on different ports. Right? All 3 of those services can't all listen on port 443. That's not a unique socket, right? We can't do that. So if I'm only using one IP address, that means I need to configure each of these services to listen on unique ports. So maybe I do SIP 5061, PSOM 444, and SRTP 443. Now I've got one IP address on the edge, and I'm happy, right? Well, from the edge server perspective, you're happy. From the firewall perspective, you're happy. From the end user perspective, we're not happy, right? And why are we not happy? I could be at a customer site that doesn't allow 5061 outbound, that doesn't allow 444 outbound. So now I'm at a customer site and I can't sign into Lync because I can't make the outbound connection on 5061 because the customer site blocks it. Maybe they only allow 80 and 443 out. Drat. I can't sign in, right? Or maybe they let 5061 out and 443 out, but not 444, right? So now I get in and I can sign in, I can do I'm in presence, I can do an audio call, and then I get into a web conference and it craps out. Well, because we can't get to PSOM, we can't get to 444. Right? We make life simpler using dedicated IP addresses. Because check it out, if we use dedicated IP addresses, look at the ports that we listen on. 443, 443, 443. Okay, most organizations are going to let you do 443 outbound. That's the reason, right? Now again, common misconception, people see that port there of 443 and they go, oh, that must be web traffic. No, it just means we're listening on port 443. Okay, that is still SIP traffic. That is still PSOM traffic. That is still secure RTP traffic. None of that is HTTP traffic. Yes, I know, it's port 443. We do that because 443 is a very common port that organizations will allow out. Let's ride the wave, right? And get on 443 and go. Okay, that's the idea. So the recommendation is, of course, to do multiple dedicated IP addresses, because that's going to be the most flexible in your environments, especially for your end users. So one doesn't require lots of public IPs, but it could limit your user's ability to connect. Dedicated IP, sure, it means more, but much better opportunities to connect for all of the modalities that we have, right? So generally speaking, we want to start with the dedicated IP, and then only if we kind of get pushed down do we want to think about maybe doing a single one. Single ones are great for labs too, by the way. Those are fun for labs because, hey, it's just a lab. Question?
Can you elaborate a little bit more how dedicated IP will let you log in if 5061
Sure, because if it's a dedicated IP, it's 443, not 5061. Cool? Yeah, even on a dedicated IP, everything's 443. The 5061, we would still use that even with dedicated IPs, but that would be for federation, and that would be server to server. The clients would not connect on 5061. Right? Externally, clients would want to connect on 443 with a dedicated IP. There it is, subnets. We got to have external and internal interfaces, different subnets, non-routable. Simple, right? It's written in TechNet documentation. It's been this way forever and a day. I know a lot of really smart people that have managed to get this to work with a single NIC. Again, I'm not saying it's not technically possible. I'm simply saying it's not supported. Right? This is the supported method in which to deploy edge. Firewalls, a couple of screenshots here that show you, this is straight out of the TechNet documentation, so I'm not going to spend a ton of time on it, but this is just showing you what the firewall ingress-egress looks like from a ports perspective. So here you see a snapshot of the reverse proxies, right? And you can see the HTTP or HTTP-REST request, so that's 80 and 443, right? And then getting redirected either to 8080 or 4443 or 443, depending on what it is, right? Everything gets directed to 4443 except Office Web App Server. Right, Office Web App Server would get directed to 443. That's why that guy is on the chart there. We put a little arrow to let you know that that's new. Right? Because if you just follow the 2010 documentation, you won't find that one because we didn't use Office Web App Server in 2010. The firewall ports for the edge. Firewall guys love to see that. Right? They actually do because it's well documented. Right? It's not scary in the sense that it's well documented what ports we need. There are some new ports to call out here between 2010 versus 2013, like the XMPP one that we mentioned before, which there you see it on both sides, right? 5269 on the outside and 23456 on the inside. We also have these 50,000 ports, 50,001, 50,002, and 50,003 to the inside of the edge. That is for what we call CLS, or the Centralized Logging Service. How many of you are familiar with OCS Logger for monitoring Lync servers? Yep. How many of you are aware that OCS Logger is no longer included in Lync 2013? Yeah. How many of you are happy about that? Yeah, I'm happy about that. I like CLS. Anyway, Centralized Logging Service is meant to replace OCS Logger. You can still get OCS Logger from the debug tools. There's a few caveats if you want to do that. So if you happen to be someone that's using OCS Logger from the debug tools, come up and see me afterwards, and I'll make sure that you're using it right. But eventually, we want to be able to get everybody using Centralized Logging Service. The 50,000 requirements. This is probably the most commonly asked question that we get with regards to Edge. And again, I'm not going to go into great detail on this. I have a much deeper dive of the 50,000 ports and media flows in my TechEd session from last year, so I'll get you the link for that. But we get this question, if you look at the documentation back here, you'll see this port range at the bottom left. RDP, UDP, TCP, 50,000 to 59,999. And invariably, like the firewall admin's eyes immediately go, what? You want me to open up 10,000 ports? You must be joking. I'm not going to open up 10,000 ports. And they just leave the discussion at that. Right? Not realizing that you're not blindly opening 10,000 ports. Okay? The mediation servers, the edge servers are not blindly accepting connections on any of those 10,000 ports, right? In order for you to be able to exploit that, you would have to be able to not only compromise the MRAS token, but find the exact port that the user is allocated within 10 seconds of the edge server allocating it. Chances are pretty low that you're going to bust into that. But again, it's 10,000 ports, so they go, no, it's not that bad, okay? If you're federating with OCS 2007, you have to open that port range to your AV Edge IP. Right? Because OCS 2007 is just not intelligent enough to be able to do anything other than talk media on that 50,000 port range. So if you have to federate with an organization that's running OCS, the R1 version or RTM version, you got to open it or not federate with them. Right? Or tell them to upgrade because it's like way old. Right? If they're on R2 or 2010 or 2013, you'll see in our documentation this lovely little nugget. We require 50,000 to 59.99 TCP outbound. What the heck does that mean? TCP outbound. Well, what they left off is we need that port range as TCP outbound as a source, with the destination port being 443. So if your organization already allows outbound 443 from the AV edge, then that's irrelevant to configure this TCP outbound piece, right? So you see here source, destination for the first two, AV edge, service interface, any destination IP, destination port 443. If we were to follow their guidance of require 50,000 to 5999 TCP outbound, it would look like that. Well, if the firewall guys aren't restricting it based on source port, well, then if they allow any source port, then you're good to go, as long as the destination is 443. That's the bare minimum that we talk about. Now, I say bare minimum because if you do it this way, it does work. It's not optimal, okay, but it does work. If you want to know why it's not optimal, right, go to my session that I did at last TechEd. They've got it up on, I don't know, some portal somewhere. If you go to, I have the link later, it's aka.ms/linkEdge, right? I have a whole session that I did just on media, ICE media negotiation through Edge, that'll tell you exactly why you need that 10,000 port range for optimal purposes. We added IPv6 support. Thunderous applause, I'm sure, right? In the February 2013 CU, we've added the ability to do IPv6 support in the edge. Nice that it's there. I don't know very many organizations that are already on native IPv6 or even like starting to go down the IPv6 route. But hey, yeah, Edge server is there, ready to roll when you are on IPv6. I can tell you that once we start transitioning to IPv6, it'll be fantastic that everything in my house, including my toaster, will get an IP address, and then I won't be able to make breakfast because the DHCP server will go down. It'll be great. So, told you I don't get out much. All right, let's wrap up a couple here. Load balancing. Load balancing options, there's two. DNS load balancing, hardware load balancing. Right? DNS load balancing is the ability to have multiple records put into DNS, A records, and have logic built into the client to be able to say, okay, I've returned these 3 records. I'm going to pick that one and connect to it. Oh, he didn't respond? Well, okay, I'll pick another one and connect to him. Right? It's not just about putting multiple records in DNS. Okay, that's called DNS round robin. No, that's not what we're talking about. Right? What we're talking about with DNS load balancing is logic that's built into both the servers and clients to be able to know what to do when we get multiple results back and one of those results, or one of those servers that we get in the result doesn't answer us. To be able to have the intelligence to say, oh, server 2 didn't answer, I better go to server 1. Oh, server 1 didn't answer, I better go to server 3, right? That's intelligence. We built it in 2010 and 2013. This works for most traffic in the Lync environment, but not the HTTPS traffic. Right? DNS load balancing, there's no logic in there for it because HTTPS traffic has sessions, it has cookie states, it has all affinity, it has all these other little nuggets that we don't have in things like SIP. So we don't do DNS load balancing for web services. That's why if you look at our documentation, we will tell you, you still need hardware load balancers, right? Even if it's just for web services, you still need hardware load balancers, right? And that's because we can't do DNS load balancing with web traffic. It also doesn't work with anything prior to Lync 2010. So any of the PIC providers, the Federation with OCS, R1, R2, Lync for Mac clients, right? None of these guys understand DNS load balancing. So you have to think about that from a deployment perspective and go, wow, if I'm 90% max, I can't do DNS load balancing. I've got to put hardware load balancers in, right? Because they don't understand DNS load balancing. The option is to use hardware load balancers either for just web or for everything, right? Hardware load balancers work very well. They're just really complicated to configure outside of the web environment. That's one of the reasons we came up with DNS load balancing, by the way. We saw a lot of problems in deploying Lync and deploying OCS with hardware load balancers when the hardware load balancing guys had to configure everything, including SIP and conferencing and all that. It's just stuff they were never used to configuring. They're like, give me my web traffic. I know how to do web servers, right? So we wanted to make it easier on them and say, go do web servers and you'll be fine. Right? Well, you can use it either for just web services or you can use it for everything. From an edge perspective, we're going to need additional VIPs that point to the hardware load balancers. We need external IPs. We have to do publicly routable external IPs on the VIPs, right? And you must not SNAT on the AV edge, right? What we mean by that is the client IP address has to make it through to the edge server. Right? We can't SNAT it and make it look like all the requests are coming from the hardware load balancer. That will not work for media traversal. right? If you try to do that, you won't be able to set up calls properly. It's just not going to work. So don't do that. Yeah. Sorry, I should have said VIPs and servers. Yeah, we need public IPs across the board. Yeah, we don't do NAT with hardware load balancers. For hardware load balancers, it's public IPs all the way. So the VIPs are used to connect to the initial names, but then we actually do connect directly to the servers for media, for example. Even for edge services, for federation, right? It's all going to connect directly to the servers. Right? So we hit the pool name to get to a server, and then we talk to that server directly, not through the VIP. So that's why we need public IPs everywhere. Sorry? No. And I can, we're getting a little low on time, but I can get with you on that afterwards. So this is a look at IP requirements. Obviously, if we go the hardware load balancing route, we need more IPs because we have VIPs that we need to configure. But the advantage is on the edge side, hardware load balancers will support every scenario. Right? DNS load balancing doesn't support things like Federation, AOL MSN, the down-level clients, the R2 clients, and so forth. There's no high availability for them. So it does work, but there's no high availability. So if we lose that first server, they're done. Right? They can't connect into the edge anymore. All right. HA and DR. Well, we get HA simply by being able to deploy the edge servers in a pool or the reverse proxies, the now defunct reverse proxies, in an array. Right? And that gives us the capability of having an N+1 model. Right? So I don't just have one edge server. I have an edge pool of 5 servers, right, or what have you. And if one of those servers dies, the other guys can pick up the load. That helps us to avoid that single point of failure. DR is the ability to recover from a failure to another site. Right? So think HA being recovering from failure in a site. DR is recovering from a failure to another site. Right? So we can recover from the loss of a complete data center by doing pool pairing. Right? You remember that if you went to the HADR session on Monday. We do pool pairing on the back end, but we deploy multiple edge pools in the respective data centers. And then if data center 1 goes away, we can revert over to using the edge services in data center 2. I'll show you that here. So there's our 2 data centers, Vienna and Munich. They're paired. The pools that we have deployed are paired. We have 2 edge pools, one in Vienna, one in Munich. My user's homed in Vienna. I come in through the Vienna edge. I hit the Vienna pool. I'm signed in. I'm happy. Life is good. The Vienna site craters. Right? All that's left now is Munich. I run some nifty PowerShell commands, invoke CS management server failover, invoke CS pool failover. I fail over all of the services to Munich. I then take the edge server, edge services, and repoint them so that the user can now sign in through this particular edge, and we're off and running. Now I get that site back up. I can flip everything back with invoke CS pool fail back, get the edge services back up and running, right? This will help not only in disasters of the entire data center, it could even help if this particular pool went down. Right? I could flip over this edge to actually talk to its next hop being Munich if I so desire. So lots of DR capabilities that we have now with edge that we didn't have before. Question? Correct. That is correct. Yeah, paired pools failing over is a manual process. It is not automated. Federation doesn't fail over when that happens, right? That's why I said I've got to, repoint the edge, right? I've got to do some work because that doesn't fail over as part of the invoke CS pool failover, right? That's handling pool failover, not edge. So you might need to make some changes in public DNS to point IPs. You need to change what your federated edge is, right? Make some minor modifications. All right. Sizing is pretty straightforward. It hasn't really changed much from 2010. Right? We've got 12,000 concurrent users per edge, up to 12 servers in the pool. Your mileage is going to vary. It's all going to be dependent on, our user models are built on 30% of the user population being external. So just keep that in mind when you're doing your sizing. Edge servers really should be in every data center. Technically, you could centralize edge services, but you have to be aware of if you centralize it and you lose that central pool, you've lost edge services. Right? So generally speaking, we'll often find if you have locations that have front-end pools, there will generally be edge pools. Question I get a lot is, can I stretch an edge pool? Could I just build one edge pool and stretch it between all 3 data centers? No, that's not supported. Okay? You could centralize your reverse proxies, right? That came up earlier. What if I put the reverse proxies in data center C, right, and then had it do everything? Technically possible, but not a good idea, right? You should have reverse proxies in each of the data centers and use something like GeoDNS. That'll help you survive in a disaster scenario as well. And last but not least is to validate. Use Edge Event Viewer, validate replication. We've got a couple of links here for connectivity analyzers that can help you. And I just made it about 10 seconds over. So I'll open it up to questions, but it looks like we're out of time, so I'll bring you guys up here for questions. Hope you enjoyed the session. Lots of resources that I've got documented here if you need them, and feel free to come ping me either here or afterwards at the sessions. Thank you, guys.